This is the cosmic web, the largest structured entity in the known universe, a vast network of galactic filaments spanning hundreds of millions of light years. General relativity suggests these structures should be unstable. Based on the visible mass of stars, gas, and dust, there isn't enough gravitational energy to hold these filaments together against the internal motion of the galaxies themselves. The standard lambda CDM model addresses this instability by assuming that 95% of the universe consists of invisible dark matter and dark energy. This map of a cluster collision illustrates the problem. The pink regions show the observed baryonic gas, while the blue shaded areas represent where dark matter must be concentrated to explain the gravitational effects we see. No dark matter particle has ever been directly detected, despite 50 years of searches using deep underground sensors and high-energy particle colliders. The persistent failure to find a material particle indicates that gravity may be a secondary effect of an underlying process rather than a force generated by a missing source of mass. The new subquantum informational mechanics, or NMSI, treats gravity as an emergent interference pattern rather than a geometric property of spacetime. In this framework, the vacuum is a subquantum informational substrate, a dense medium of infobits capable of supporting complex oscillations. A central logical oscillator, or CLO, forms when these infobits stabilize into a coherent node. This node functions as the center of mass for any given object. Gravity arises through phase-locked resonance. When baryonic ladder enters a synchronous rhythm with an antiphase background, it generates the attractive force we measure as gravitation. This shift redefines cosmic evolution. Mass does not pull on mass. Instead, independent oscillators move to achieve harmonic synchronization. The mathematical engine of this framework is the Euclid-NMSI potential equation. This formula retains the standard Newtonian G/R relationship, ensuring accuracy for short-range interactions. The addition of a scale-dependent Yukawa term, defined by coherence length and coupling strength, modifies the interaction at cosmic distances. Traditional equations in general relativity and fluid dynamics frequently collapse into mathematical singularities. NMSI uses phase coupling to prevent infinite blowups and maintain global smoothness in the underlying substrate. We see this stabilization by comparing entropy evolution of standard fluid dynamics against the NMSI model. The baseline yellow line spikes into a singularity, while the blue NMSI line remains flat. Metrics confirm a 63% improvement, demonstrating stability without ad hoc parameters. Because NMSI mathematically stabilizes these coherent vacuum structures as informational halos, the extra gravity needed to bind galaxies emerges naturally, removing the need for hypothetical dark matter. The flat rotation curve problem is a direct test. Galaxies like Andromeda spin like solid disks. Outer edge stars move much faster than standard gravity predicts. The standard model requires an invisible halo of dark matter particles to provide the massive gravitational pull necessary to keep outer stars from flying away. The NMSI Yukawa modification predicts a sustained plateau of 250 kilometers per second out to 30 kiloparsecs. It achieves this result using only the galaxy's visible baryonic mass and resonance with the vacuum. This resonance-based formation is supported by James Webb Space Telescope observations of mature galaxies that formed much faster than the standard dark matter model predicted. Integrating phase resonance into gravitational equations solves the apparent mass deficit that has plagued cosmology. At the largest scales, filaments of the cosmic web emerge through constructive interference within the substrate. Baryon acoustic oscillations represent standing waves in this non-expanding medium rather than relic primordial sound waves. These waves function as a harmonic ruler, connecting galactic superclusters across scales of 140 megaparsecs. Antiphase repulsion creates vast cosmic voids between these filaments. This is a regional loss of coherence, where destructive interference prevents the formation of massive structures. Cosmic evolution follows a trajectory of self-organizing resonance, performing a continuous, rhythmic computation across all scales. NMSI is a falsifiable framework that provides specific predictions for gravitational wave propagation and anomalies in the cosmic microwave background. Researchers are specifically looking for a 10 to 20% power suppression in the low multiple range of the CMB as a definitive signature of this model. Gravitational wave standard sirens will provide the ultimate check on these scale-dependent Yukawa corrections by measuring how these signals propagate through the cosmic web. The framework offers a unified explanation for everything from planetary vortices to the largest cosmic filaments, without requiring the postulation of dark matter or dark energy. A vast, vibrating architecture of information continuously governs the physical motion of galaxies and the birth of stars. If you enjoyed this video, please like and subscribe, and leave your ideas for a future deep dive in the comments. Today's video was brought to you by Synestex Systems LLC, founded by Shane Persinger, who makes new content almost daily.